be established before you proceed to regression analysis. Yeah, that's understandable. Any other idea?
Hello, good afternoon, Doc.
Sir Jonathan.
For me, Doc, is a statistical technique that relates a dependent variable to one or more independent or explanatory variables.
Yeah, okay. So basically, regression analysis is actually a family of statistical analysis that deals with relationship of explanatory or predictors or independent variables or regressors to a dependent variable. No? And sometimes there are regression families that do the simultaneous regressions, which may include more than one regressors or one dependent variable, and that's basically part of the multivariate analysis. But in layman's terms, it's basically looking for the relationship of one or more explanatory variables to a dependent variable or the effect or the regressant or the y. So regression analysis is not only one. It's a family of statistical analysis, and it's the most fundamental modeling approach that we would be learning for this course, for this particular lesson. So regression analysis focuses on relationships between variables, which means that before you can proceed to regression analysis, there will be some sort of estimation of relationship. So, for example, you need to relate or associate or establish the possible nearness or magnitude of the relationship between two or more variables before you can actually proceed to regression analysis. However, particular characterization focuses on the simple, practical, ordinary least squares approach. Okay? So when we say the simple linear regression analysis, it's one variable affecting the other variable, and the other one is multiple linear regression analysis. That means two or more variables being established or being sought to establish linearity of relationship to a dependent variable. Now, it's one of the most commonly used tools for business analysis because it provides us not only relationships, but the amount of change of independent variable or combination of independent variables or a gradual increment of these independent variables to a dependent variable. Meaning to say, may estimate mo ang changes or ang effect of isang variable combination here in specific modeling approaches that you will be doing. So, ano ba ang magiging implication ng changes of the mean in business analysis? So, you would now have an empirical basis in establishing gaano kataas or gaano kababa if in case we would decide to increase this particular variable. That means that for you to control your dependent variable, you need to processes or you need regression analysis to estimate the possible changes will bring to your dependent variable so that you can actually prepare for similar scenarios in the future. Dapat ganito yung combination of specific variables so that you can attain something like this. So in a way, it's doing prediction. Now, it's easy to use and applies to many situations. However, regression analysis is not only pertaining to linear estimation procedure because that assumption for ordinary regression. Estimation follows sabihin nito, kailangan sunod so that you can establish the correct fit, the correct predictor based on given observation. And that linear bias is possible prediction model that can capture reality of your dependent variable given this combination of more than one variable affecting together this parameter. So may mga possibility ng isang variable, isang y hindi lamang affected ng isang variable. May possibility naman that we can establish a linearity or relationship with one variable, but then the unaccounted variable or the variance
Unsa?
that is
Nga klase?
okay, so the unaccounted variance of the dependent variable of the other independent variables that were not counted for in that simple linear regression would actually factor elsewhere in the equation. So medyo kailangan natin talaga i-discover on how or what would be the best approaches in exploring the correct variables that we can include in the equation. And suffice to say, there is no such thing as the perfect number of variables that fully explain 100% of everything. Okay? No worries, no worries. Can understand. Pinilagay mo akong computer ang ganito. Okay, so as I mentioned kanina, there are two types of regression analysis under the classical approach. We have the simple linear regression analysis. That means there's one X or one single explanatory variable. The other one is multiple linear regression analysis. That includes any number of X. Now, itong question na to, lalabas ito sa conference. Usually, tatanungin kayo or bibigyan kayo ng situation in which you would be requested to create multiple linear regression analysis based on an identified number of variables na na-discuss sa ating sa situation. So, be prepared for this. Okay, so some terms lang for us to be familiarized. Hindi lahat ng variables are independent or dependent variables ang nomenclature. So that means there, you would be encountering terms like exogenous variable in a specific regression analysis approach. So there could be some modeling and statistical techniques that would use the terms X and Y or X sub 1 to X sub n. Or there could be terms used like regressors and regressants. There could be terms like explanatory variables and dependent variables or the cause and the effect. So whichever terms are used in those texts, they're actually pertaining to this common term, which is the dependent variable and independent variable. So a dependent variable is a single variable being explained or predicted by the regression model. So remember that not all dependent variables are expected are in a way in the regression family, hindi lahat ng dependent variable are linear, which means that you cannot expect that they are scaled or continuous or interval all the time. But in classical ordinary least squares, it is always expected to be continuous or interval in nature because you are estimating the mean. Okay? So you are estimating for an increase or decrease in that dependent variable based on the effect, whether it's simultaneous or individual or gradual increment. So whether there are variables there that are categorical or nominal or ordinal or continuous or interval, the dependent variable has to be continuous in a simple linear or multiple linear regression. So then again, the dependent variable is that term because it depends on the changes brought about by increase or decrease of your dependent variables. So independent variables are also termed as explanatory variables because they are used to predict the dependent variable. So in such a case, they're also called predictor variables or predictors or explanatory variables. Okay. What difference between Pearson R and regression? Okay, basically we are actually comparing here. You're comparing here a specific test of relationship and a test of magnitude of relationship, or you are comparing here the correlation coefficient and the coefficient of determination. Okay, so Ang Pearson R is a parametric correlation analysis, a parametric correlation test, which means that for it to be parametric, it has to follow specific properties, no? Statistical analysis that includes efficiency and randomness of your sample size. When we say sufficiency, dapat sufficient enough to account for the population, because parametric statistics it's very particular with representation in your sample or the characteristic of the population by a handful of samples that you have. Second one is the data should be normally distributed. For you to proceed to Pearson R, you need to have your data to be normally distributed. That means in the estimation procedure and when you're going to plot your data set, it should follow a bell-shaped curve, which means that there could be increasing number of instances in the middle and slimmer number of instances on both sides ng siya. Ang ibig sabihin ng kukonti dapat ng dito because these are extreme regions here. And, you know, if it's not normally distributed, for your data that does follow a possible linearity, in case there are a lot of values that are either very low to the point that it's away from the average and very high to the point that it's away also from that average. So that's one of the conditions, or those are the conditions of correlation analysis. Now, in regression analysis, ito yung sinasabi nila na ang Pearson R is R, ang regression is R squared, but you're going to square the value of your Pearson R, and you can actually determine the coefficient of determination. And that's basically true. Now, in regression analysis, you are not estimating just the closeness of the variable. I've mentioned last time, in Pearson R, you are computing for a specific area in a Venn diagram that those 2 or 3 or 4 variables actually meet together. For example, meron kang dalawang circles in a Venn diagram. The area where they meet together, or the area that's common to both of them, is the R value. Now you square that, and that's the value in the coefficient of determination. What computes for the correlation or the possible consistency or nearness of the 2 or more variables? Regression computes for the changes of the mean in the increase of your independent variable. So in case your independent variable, what would not be the effect to the dependent variable? Would it increase or would it decrease? So in another sense, regression cannot proceed without correlation. And regression, or the specific ordinary, this particular example, the ordinary squares regression analysis requires a parametric correlation for you to do. Okay. So here's what I'm talking kanina. No? So linear regression establishes or assumes a straight line relationship. That means a possible increase of your x could increase your y. So the functional form y equals mx plus b gives us that at a specific scenario, specific situation, y can be explained by a specific constant value plus a specific change of the mean of your x, whether it's positive or negative. So the mean change there is seen as the value m, or as the letter m, which means it could be positive or negative. If it's positive, that means your y will increase. If it's negative, that means an increase of your x would decrease your y, and vice versa, or inverse, which means that if in case you increase x, mag-decrease your y. If you decrease x, mag-increase your y. Plus b there, which is actually the constant or the expression. So this contains the values of other variables that we might have not included in the estimation procedure, or we have not counted. So dyan papasok yung constant value. It seems to decrease. The value of your constant of your linear regression will usually decrease in the addition of another 1, 2, 3, 4 variables, which serves as your x, as additional x. So that means that This would be mx sub 1 plus mx sub 2 or m sub 1 x sub 1 x sub 1 plus m sub 2 x sub 2 and so on. So, bababa yung value ng ating b to the point that it gets closer to 0 if in case we're nearing or we have already accounted for the number of variables that could likely increase near 100% of the variance of your y. So far, akong nakitang regression analysis which has several variables that explain 100% of your y. Because then again, there is no perfect relationship, much as there are no specific variables that perfectly explain the existence of another y. There could be, but it's very impossible. It's possible, but it's not really easy to determine what variables explain this particular y at a specific point in time. Now, there's another regression analysis, the nonlinear regression family. They imply curve relationships, or in some cases, it could be quadratic, it could be logarithmic, it could be binary, it could be an S-shaped distribution of your responses. Regression types. So in case you heard the legit or the logistic regression, they could be ordinal, they could be multinomial or nominal, or they could be binary logistic, so hindi ang linear relationship. So makikita mo yung mga curve, makikita mo yung mga responses when you plot the regressors and the regression in there. You can see the difference because in regression analysis, it follows a linear relationship. And what does a linear relationship look like? I will show it to you later using numerical approach. Now, there are specific data types that we use in regression analysis. Una, protection data, that's data gathered from the same time period. That's not necessarily that you're going to get them at the same hour or at the same month or the same week. But for a specific period of time where conditions from time interval or from time A to time C, time B are the same or uniform. So that's why in specific survey studies, you are asked on the length of time that you're going to gather your data and the conditions and the environment that is suitable for that is accounted for in your data collection. Because what we're looking for is establishing that your data in a cross-sectional survey is taken at the same condition. Talagang inaingon nato or yung sinasabi natin, syempre kapag ang study mo is principal leadership, hindi mo masisiguro na yung principal ngayon mag-i-exhibit ng specific ng same leadership style. So at this particular point of time, that principal behavior can actually change from time to time. So it could give impression, or it could yield specific values in the survey as perceived by different teachers or as perceived by different parents as 5, 4, 3, 2, 1. That's why in a cross-sectional study, as you establish that the data is taken in a specific length of time where the conditions are the same, that will actually suffice. Or you can actually establish the reliability of your data. That means that your data has been taken on similar or almost similar conditions. So yun lang din yung argument natin sa cross-sectional or survey data, because in the first place, it's based on perception. Okay? Now we have here time series data. So it involves data observed over equally spaced points in time. So that means at a specific interval T, there is a specific data. So it might be, that means there could be values for this particular month, this particular month, this particular month, this particular month. If this every year, of annual, so year 1, year 2, year 3, year 4, year 5, dapat meron tayong data chance. So that we can establish for possible predictions that are reliable based on their complication. Because your data is present in equally spaced points in time. Possible ba na meron tayong time series na monthly, combination ng monthly, at quarterly, at annual? Much as possible, wala pang ganun. Because the specific element that we're looking here is the consistency or equality of the space points in time of a time series data. So dapat yung T natin is ma-establish talaga natin as T1, that means annual, T12, that means monthly, or T4, that means quarterly. So dapat consistency tayo. Okay, so when we talk about linearity of the relationship, we're talking here of a graphical illustration of the possible relationship of these two variables. So there's a particular data set here. We have here square feet. I guess it's square feet of a specific material and the cost of that in terms of dollars, maybe. And I wish usually in Microsoft Excel, we highlight these two data and then we will use specific charting commands here in Microsoft Excel to establish the possible relationship of these two variables. At one point, whether you are using statistical analysis already, the graph will tell you of the possible linearity of the variables that are being used here. So for example, makita mo dito sa scatter plot natin ng graph, do you think this particular data here, do you think this particular data has a linear relationship? Based on your impression, do you think it follows a linear relationship? And if so, what kind of relationship would that be? Is it positive or negative? Jonathan?
Based on the graph, Doc, clearly upward ang trend or upward ang direction ng data. So I can say there is a positive but not so strong. I can say maybe it's a moderate or a fair relationship between the square feet and the cost.
Yeah, that's good. Very good. That means that there could be, we can actually suspect that there's a positive linear relationship here because we can see that the direction of the data set at different coordinates or points of X and Y. Each particular dot contains two values. That's the value of your X, which is your square feet, and the value of your Y in terms of the cost. As we can plot these particular dots or values of different coordinates here in your XY axis, we can see that there's a trend and that's increasing. We can see here that there is a possible positive relationship between the cost, but as to the nature of the relationship, we can suspect that it's not really very strong, considering that a strong or a nearly perfect relationship follows nearly a 45-degree angle, which means that a specific point of time or at a specific point of time, that means that specific location of that data set or that data point of containing X and Y values may follow like a 45-degree angle. In case it's near 45-degree angle, we can actually say that it's nearing a strong relationship. Pero since this one looks a little bit cluttered, but the direction is upward, we can actually say that there's a positive relationship between square feet and the cost. Now, I don't know if in case I have illustrated last time on how do we, I guess in the last face-to-face relationship, I showed you a specific approach of automatic correlating or computing the correlation value in Excel using the Corel function. And there's one that tries to, we graph that particular data set on enrollment, and then wala na ko nag regression, I immediately graph it and show the equation. So of checking the possible relationship of the two data or two or more data in that case. Now this one is a scatter plot. You can see the scatter plot can actually be used to detect possible relationships as here. And the trend line would confirm the possible linearity and direction of the linearity of your relationship, which means that if in case it's upward, it could be a positive relationship. If in case it's downward or leaning uh, downwards from the left area to the right area, then there's a possibility of a negative relationship denoted with a negative value of your correlation. So kapag ganyan, pwede mo siyang i-right click, pwede ka mag-add trend line, pwede ka mag-add ng equation para malaman mo na kung ano ang possible beta coefficient or the value of your m or the value of y and you can do so immediately using the graphical and just displaying the value of the equation. So, So the scatter plot is a graphical approach in displaying regression analysis. While I maintain that regression analysis is statistical in nature, it's also a little bit data science, or it's hinging on concepts of data science, because kung ang tinitingnan natin is not probability, but rather the values of the data of your um, the distribution of your value in this particular graph. So, kung makita natin at one point na mataas pala yung relationship, that means that this particular variable or the square footage could actually explain a specific variance of the cost. If in case dadagdagan natin yan ng another variable, the relationship could improve, which means that there could be other variables that could be added in the regression to improve the fit or improve the trend line's direction, or improve the values of or improve your equation or your prediction model. So scatter plot is a graphical approach that displays relationships between these variables. I'm not so sure if we can produce a scatter plot. I haven't tried generating a scatter plot using more than one variable, because in my illustrations, it's always one x and one y. Isang x by y. So in Excel, we can actually establish the correlation value by computing using this equals correl command, and it involves computation of two different data aligned in an array form, which means that it could be something like that, vertical array, or it could be horizontal array. Okay, so Corel will calculate the correlation between the variables. It would be implemented in this particular format, equals Corel array x and array y. Or you can immediately compute that using tools, data analysis, and you click correlation. If you still allow me, I have here a data set. I'll establish this one. So, kapag naka-formula yung data ninyo, you always use space values so as to maintain the actual data. And then I'll compute for the other variable, which is energy. And I'll send this to you in the GC so that you can compute with me. So let energy of your x and surface of your y. So energy here represents athletic mental energy. And the surface here is athlete satisfaction. So save this one as @_1. Okay, I will close this a bit. I'll send this to you in the GC for you to compute it. Please confirm if you have received the file. Can you see the file in the GC? Please save that. And then confirm if you have received it.
Wala, Doc.
Mag-share ako ng file nasa GC natin dito sa Zoom.
Nasa chat room, Doc.
Sa meet natin dito sa Zoom. I share the file.
Nasa chat, Doc.
Nasa chat, okay? So wala sa messenger na GC natin. Nandito sa chat room, nasa meeting chat natin dito sa Zoom. Kindly save that because that will be our activity 1.0. So in computing for the correlation function, we usually use this particular command for rel, open, and then highlight the array, which means that you need to highlight the first data colon the last data of the first array, and then comma, the array point to the first data of the second array, colon the last data, or you cover that last data, then close. So this one should be Carel, equals Carel, open and close parenthesis, first array A2, colon A342, comma, second array B2, colon B342. As much as possible, it has to be matched because in correlation analysis, it's usually match a sample. We match number of observations for each variable. Okay, and we try it, then hit enter. You can actually see here that the relationship is about 30.77%, or the R value is 0.3077. This could be like a weak relationship. Maybe a weak relationship for sure. But yeah, it's more than 0.25, it's moderate. This seems to be a moderate relationship. If in case you're not comfortable with that array function, what you need to do is data, and then you go to data analysis, and then try to select correlation here, and click OK. Range, if in case label for label, so highlight the first array or the input array, including the title. I'm sorry. That includes pala the, sorry. This includes the array of the second variable. So, you highlight both of them. And regression, isa-isahin niyo talaga ang yung IV at saka DV. But for correlation analysis, you highlight both of them, including the title. Once you highlight the title or the name of the variable, make sure you click labels in first row, so that the labels there that you have highlighted will be skipped in the actual analysis and will not be treated as the data. But if in case hindi niyo siya sinali, yung labels, you just unclick this one, so that the analysis would detect that walang labeling, wala kang labeling. So check natin siya. You can actually click output range. You can actually identify whether the results would come here, or it could be in an output range where you can decide to create another sheet, depende yan sa'yo, or another one. So in my case, since I know that correlation analysis will take up just a little bit spaces or number of rows and columns, I'll just click this particular area here. Afterwards, So as you can see, there is consistency in the results. When energy and energy is correlated, it's one because pares lang ng variable. But when energy and satisfaction is correlated, the correlation value is 0.3077. Same kanina sa ating correlation. Okay? Now, here's how we interpret the values of our correlation as an input to our regression. The correlation describes the strength of a linear relationship, which means that it basically investigates the closeness of the variables or the likeliness that they are similar or that they are related with one another. So it is described as between -1 and up to 2. Although there is no such thing as perfect positive and perfect negative relationship, values that are near -1, +1, very strong relationship. But make sure the value is hindi siya lalagpas ng 0.9. Kasi likely, the variables that are being correlated is there, or the two variables may be the same, and it should be categorized as a third distribution. Now, -1 is strongest negative relationship. That means perfect inverse relationship. A positive one denotes as the strongest or perfect positive relationship. That means an increase of x by 1 will also give you specific. For example, if in case 1 is if in case 1 is to 1, if in case mag-increase ka pang 1, kung another 1, then mag-increase ko siyang 1. If in case na 1 is to 2, ang nakita na ito a perfect relationship, if in case magdagdag ka 1, madungadan ka 2. If in case magdagdag 2, madagdag, madungadan ka 2. So yung anak siya ka-perfect, which means na wala siya batal or that all predictions are exactly yielding the same amount or mean change whether it's increased or decreased. Now, a relationship or an R value that is close to that is 0 means that there is no apparent relationship. That means that the two variables being correlated are independent from each other. Anong ibig sabihin ng independent, Mr. Cantor? What do you mean by a zero correlation value?
Hello, Doc.
What do you mean by an R value of 0?
No apparent relationship exists, Doc.
Okay, no apparent relationship exists or that they are independent. Which
Yes,
means na kahit anong gawin, isang variable, gano'n siya mag-increase or mag-decrease, wala talaga siyang may change na makukontribute sa other variable. So which means that they are independent and that they do not affect one another. Okay? So the simple linear regression model estimated with the hope of getting the blue or the best linear and biased estimate. So this one follows, or the simple regression model follows the ordinary least squares approach as this observation procedure. Need to say we can establish the number one, we need to have a linear relationship. Pangalawa is we need to establish that both variables are correlated before we can establish that it predicts another variable or your x predicts the y variable. And third is you need to establish the specific best fit of the relationship of the two. Because if in case your intention is best linear and biased estimation, then that means you are prediction or explaining or establishing whether x explains y. Now, as you can see here, let us remember our basic lesson in algebra before, the concept of the rise and the run, or the slope and the intercept. So, kanina, ang function of equation natin is y equals mx plus b, okay, which is this one. Now, it can actually be extended into this working equation, y equals a plus bx plus c. where E there is the error term. So according to Bach, so Bach is one of the authors or one of the one of the statistical authorities in regression analysis that includes his works on time series model or time series models, yung baka narinig mo yung Bach-Jenkins model. So Bach, one of the founders or one of the pioneers in the field of prediction modeling and predictive analytics or prediction or the science of prediction, actually said that all models are wrong, but some are useful. So sinabi niya, lahat ng ating models are always subject to specific errors. So that's why we need to extend our y equals mx plus b to account for the value of the slope, which is your x here, the value of your slope of which denoted as f, the value of your intercept as b, plus the value of your e, which is your error. So y equals a plus bx plus e means that your a here is a coefficient of your intercept or constant. B here is the coefficient of your x or your explanatory variable, and your e here is error term. I'm not so sure if we can determine in regression analysis the value of the unaccounted variance. Usually it's just 1 minus the value of your r squared, which means that this specific variance may not be necessarily included here as a value to be displayed, but E here represents the errors or the stochastic error of your regression model. So basically, ang naka-value is ang variable A o variable J. Pero ang variable na-value is ang A o ang E lang J. So error term there or E is represented as stochastic error. That means that E indicates the presence of errors in the prediction. So in simple linear regression analysis or the simple linear regression model, one of the characteristics is precision, which means the acceptable measure of accuracy, that is mean squared error. So Jonathan, what do you mean by mean squared error? Jonathan?
The smallest possible, yes, Doc. The smallest possible error that can be achieved from the actual and the forecasted value or the regret value.
Correct. So the average of the difference between the actual and the forecasted is your mean squared error. Meaning to say, we need to achieve or we need to ensure that in order for us to have a precise regression model, we need to decrease our error. That means that the value that is the actual data set should be near or not too far from the forecasted or predicted value, so that we can actually see that the prediction is close to reality. Kaya nga, ang sinasabi palagi sa prediction sa classes in predictive analytics, you should always display the ranges of your confidence interval. So confidence interval has to be displayed because your prediction based on the coefficient given in the second column is not always the case. Because then again, our regression contains stochastic errors. So since the prediction is not a precise output of regression analysis, what we can do is to provide the possible ranges of the mean change at 5% confidence level, whatever confidence, at 95% confidence level, detect margin error, so that we can actually adjust to its value. Nagpinagkape ako. So sorry. Anyway, ang sinasabi natin is, kung ang beta coefficient niya is 95, it's not always 95. If in case you would simulate another round of data set for it could be less than that, but not less than a specific value. Or it could be greater than that, but not exceeding the possible maximum value. So that's account for possible error. If in case ang values ng ating confidence intervals malalayo, that means the error is very high. But if in case the beta coefficient or the value of your slope displayed in the beta with a specific value of beta coefficient, if the value of the minimum or the maximum is not so far from that, then that means that your error is minimal or you have achieved a precise or nearly precise model that would explain your y, or that would explain the relationship of your x and y. So precision is one of the criteria in judging for a good model, not only in regression analysis, but in some other predictive analytics approaches that we will be discussing. So in fact, precision, recall, F-measure, error rate, these are the common standards in identifying whether a specific model is good. So as we have mentioned, precision can be achieved if the value that is predicted is close or equal or equivalent to the value that is actual. For example, if this particular data set or this particular instance is 95 and 95 and the predicted value is 93, that means the error is 2 or negative 2. Or something like that. The variance is 2. You mean to say it could be less than 2 or greater than 2. Kung 2 ang difference, that means medyo duol-duol ito ang prediction. But if in case ang prediction natin 108, kanyang actual is 62, that means napakalayo ng difference. So a difference of 46 points, which is basically napakalayo. So we need to minimize that in order for us to have a better regression model that explains your one. Now, in regression model, we're looking here, in order for us to establish precision, we need to get the average square difference of the actual and the forecast. Now, the smaller the value, the better your forecast, or the better the regression. Squaring makes the difference positive, and severity of large errors is emphasized. So whether or not ang ating value is positive or negative, the important thing here is that the difference should not be very far so that we can have a more reliable prediction model involving your x, and y. Now, error is defined as, or it's actually known as residual. It's the difference of the actual data point and the forecasted value of the dependent variable y given the explanatory variable. As you can see here, there's a trend line here. This is basically the equation, the regression equation that explains or that graphs the possible forecasted or predicted value of your x towards y. However, your data set there is the actual value. That means that at a specific point, this particular point here is simulated to be here. It's simulated to be part of this particular line. However, it is here in reality. So that means the difference between the two, as expressed by this particular red line, red arrow, the difference of this point and this point is actually the error or the residual. So you get to square the difference of that. That means kung pagtutunan natin ng pansin yung iba, this particular data here has a very minimal difference with this particular line. This one has quite a large variance here. This one has the largest, I guess. This one is close to the fifth. So tutunin mo yung difference yan, i-square mo, and then try to check whether or not the value is large or small enough, the smaller the value or the more consistent, the smaller the value of the shared error or the error from the actual or the smaller the value of that predicted or forecasted value with the actual, the better your fit is. Now, as I mentioned, in Excel, meron na tayong specific way of computing regression. You don't need to have SPSS to begin with. So, kanina, pinakita ko sa inyo yung aking command. What you need to do for activity 1.1 is to compute for the correlation value using Excel. So, activity 1.2, using the same data set, we're going to run it in a specific software that is already installed in your computer. So, meron na ba kayong just software?
Doc, SPSS ito ang gamit ko.
Yeah, SPSS. Okay, SPSS is fine. We also have, if in case, sino wala pang SPSS?
Wala po ako, Doc, lahat.
Wala ka lahat. So, ang gawin natin, punta tayo sa Google, tapos hanapin natin si Dash. And then, what you need to do is download Just, click it here. And then, kapag Macintosh kayo o Apple computer kayo, download according to the OS that you have. It could be Intel naman or Apple Silicon. So you can just select which particular version you have with you. So if in case Windows kayo, just download this particular link here. If in case you're using a 32-bit system, the specific website would actually give you a 32-bit version. But since mine is 64-bit, it would give me 64-bit automatically. If in case hindi tayo ng computer ninyo ang current na version, we have earlier versions. In just there's specific link here for the earlier version. But nevertheless, kind of download it. And then straightforward, pwede nyo siyang gamitin for your analysis. Or alternatively, you can go to this particular link. It's tinyurl.com/EFA seminar. Okay, I will display it here. So, ipaanin ko ang laptop ko ang screen. This is an earlier version of it will need my browser. And you can download the best early version, which is very easy to be installed in your laptop. And hindi lang siya compatible sa Mac operating system. Okay. So kindly download the software here. And then kung nakita nyo na hanapin nyo yung just 0756.1. Once you find it, you download it, you click that, and then click download. So it would prompt you to download a raw file. So antayin lang natin siya matapos. Kapag matapos din na siya, it would basically look like this. Kapag natapos din na siya, it would basically look like this particular. Ang gagawin nyo, Right-click nyo siya. Tapos, extract to just file 6 backslash. You click that, and automatically all the files will be saved in the folder. Something like this. Kapag natapos na, you go inside, and then find the specific folder that you have here. So para hindi siya ma-delete, ang gagawin nyo, you right-click that, tapos send to so that it is the okay? Nasusundan ba yung aking instruction? So again, the link is tinyurl.com/ESE seminar. ESE is capital seminar. We'll give you like 5 minutes to do the installation, or you can ask me questions directly. You can give. Wala po akong data analysis sa Excel. You need to activate that in your in-home settings. It's